So first off, make sure you write your name on in case you lose it. All right? And we are in block 2 of day 1. Okay? So this unit, as I was saying, is composed of 2 parts. First part, we're going to do it before Christmas. Next part will be for the first 2 weeks after our winter break. Right? And we'll be done the whole polynomials unit before end of term 2. All right? So in general, I think this is probably going to be one of the easier units this year. Okay? For this chapter, you just need to memorize some terminology and know how to add and subtract integers. Right? If you can do that and apply it to what we're doing here, you're going to be fine. People usually do really well on this chapter. All right? So this chapter, we're going to start talking about algebra. And algebra is a relatively new concept for you guys. So that's why we're starting at the basic stuff. Okay? And what is algebra? Algebra is when we start using letters. And you can see letters like right here, here, here. Right? And these letters represent numbers that we just don't know their value of. Right? So they represent unknown numbers, and they're called variables. Okay? So the goal for today's lesson is, hey, we're given expressions like this. We want to be able to come up with their names, right? And be able to state their degrees. Right? And the degree helps tell you what the graph looks like. Right? So this way we can communicate about different kind of algebraic expressions. All right? So polynomials, that's all these kind of expressions, are made up of something called terms. And if you can count how many terms an expression has, you can tell me its name. Okay? So how do you determine how many terms does an expression have? Terms are separated by or connected by addition and subtraction symbols. Okay? So if we have this example here, right? And if you just, I'm going to highlight the subtraction symbols here, right? And if I just draw maybe a vertical line through them, maybe to help separate them out. The amount of objects in between these lines, you have 1, 2, 3. That's how many terms are. These are called terms. So the terms separate, are the ones separated by these adding and subtracting symbols. So this has 3 terms, right? So you just look at adding and subtracting symbols, and you count how many terms are in between, right? And once you can count how many terms there are in between, we just label them. We give them its name. Okay? So for example, if something has 1 term, something like this, because it has no plus or minus signs in between, right? This has a name called monomial. Monomial. Okay? 1 term. Okay. Over here, the second one here, it has 2 terms. A term here and a term here. So you need to get really good at identifying terms in an expression. It has 2 terms, right? And this is always called a binomial. All right? The next one, if you look at here, oops, I wanted the highlighter. Adding and subtracting symbols here. 1, 2, 3 terms. And this is called a trinomial. So all of these things end with the nomial. Right? The first part tells you how many terms there are. Mono, bi, and tri. That you have to memorize. Right? So I like to think of it as a bicycle. It works for most of these ones. A bicycle has 2 wheels. Bicycle, binomial. Tricycle has 3 wheels. Trinomial, tricycle. And the only one that sort of doesn't work with the 1 wheel, we call it a unicycle, but monomial. Okay. Now, those are the names for the first 3 terms. And there's names for everything going forward, but we just don't refer them to the names anymore. And anything with more than 3 terms, we just call polynomials. And that is a general name. Poly meaning many. Right? So if it has more than 3, we just call it polynomial. Technically, all of these are polynomials. That is just the general term. Okay? So let's practice this. Go over to example 1. Right? First expression. How many terms? We'll list all the terms, and we'll go back and name it. How many terms do we have here? First one. 1. There's no plus, minus sign separating anything. Just 1. Okay? Second one. Right? Put a line through your plus, minus signs, or highlight, or whatever you want to do. How many terms do we have here? 3. Okay. How many terms does the third one have? 2. Right? Whoops. Jumped. Right here. A term here and a term here. Okay. How many terms does the third one have? Or fourth one, sorry. Lachlan? 2, yeah. A term here and a term here. Okay, the next one. How many terms does it have? Abby? Just 1. There's no plus, minus sign separating anything out. Just 1. Okay, last one. How many terms does it have? 3. 1 here, 1 here, 1 here. Separated by the plus, minus signs. Okay. So now, just quickly practice writing the names down. Right? That's something you have to memorize. I'll give you like a 5-second head start, then I'll write down the name. So is it a monomial? Is it a binomial? Is it a trinomial? Is it a polynomial? So just write it down. 1, monomial. 2, binomial. 3, trinomial. All right? I'm hoping you came up with these answers, right? Should be pretty straightforward. Bi, tri, mono, and poly. Right? You guys gonna have a quiz next class. One of the questions is gonna be, can you just name it? Right? The other questions is gonna be, can you give me the degree of it? And that's what we're gonna talk about next. Okay? So now that we know how to identify terms, each term also has something we call a degree. All right? Okay, something we call a degree. What happened? Not there anymore? Huh. All right. So something we call a degree. Okay? So now a degree, what a degree tells us is the shape of the graph. Right? So it gives you the ability to just sketch a picture of the graph without having to create a table of values. Right? So if something has a degree of 1, it's going to be a line. right? Either a line like that or a line like that. And you guys at the grade 9 level don't need to know what the graphs look like. That's in a higher grade. But right now, we're just doing the baby step to figure out how to get there. Right? If something has a degree of 2, it has like a U-shaped graph. And if something has a degree of 3, it has a graph like that. Or its mirror graph like that. So how can we find the degree of a term? What we do is we add the exponents of the variable, right? And that, by figuring out what the degree is, we know how the graph looks like. So in this little box right here, we got some sample terms, okay? The first one is we look at the variable and we look at its exponent. What's its exponent here? So this is going back to September when we started talking about exponents. If you don't see an exponent, there's an imaginary number there. What number is there? Taylor? There's an imaginary 1. Okay? So there's only one exponent, so there's nothing to add. So this thing has a degree, this term has a degree of 1. Okay? Now, the second term that I've shown here has 2 variables. Has an x, has a y. So you need to add the exponents of the x and the y. So what's the exponent for the x? 2, yeah? What's the exponent for the y? So the degree, so the degree of this term is 2 plus 1 is 3. Okay? The 12. What's the degree of 12? Yes, 0. Right? It doesn't have any variables. There's no letters, no x's, no y's in here. Right? So its degree is 0. Right? So that's how you find the degree of a term. Now, for an expression is made up of more than one term. Because we got a term here, here, and here. To find the degree of an expression, we find the degree of each term, and we pick the biggest one. Because the biggest one overrides its properties compared to the rest one, all the other ones. So here, we identify the terms, which we did. And now we find out what's the degree of the first term. What do you think, Sartaj? 2. Okay. What's the degree of the second term? 1. What's the degree of the third term? 0. So the degree of this expression is the highest degree we just said. Right? So that would be, in this case, 2, the biggest one. Okay? So now, let's do some more practice. Let's find the degree of these expressions. Right? So you need to find the degree of each term. What's the degree of the first term here? What do you think, Chase? 2. There's only one term there. So this is 2. Okay? Now, the next one has 3 terms. So we need to find the degree of each one. Jacob, what's the degree of the first term here?
0.
No. There's a letter here. The letter has an imaginary number here. 1. So this is a 1. What's the degree of the second term?
2.
2. What's the degree of the third term?
1.
What's the biggest number you said, Jacob?
2.
There we go. Okay. Next question. Find the terms. Everything we're doing is finding the terms. Okay, there's 2 terms, a term here and a term here. What's the degree of the first term? What do you think, Abby?
1.
What's the degree of the second term?
0.
Yeah. So the biggest number we said? 1. Okay. Next one. How many terms do we have? How many terms does this one have?
2.
2. Okay, first term. What's its degree? 2. That's the exponent. Second term. What's its degree? What do you think, Ivan? It's a tricky one.
1,
No.
2.
2. Because this one has a 1 here and a 1 there. So altogether, 1 plus 1 is 2. So that was the trickiest one out of all these ones here. So what's the biggest degree that we have? 2. So that's the degree for the expression. Okay, next one. We have a letter. What's its exponent?
0.
No, it's not 0.
1.
It's 1, right? Every letter has an imaginary 1 at least there. Okay, last one. How many terms do we have? 3. Okay, first term, what's the exponent? Second term, what's the exponent? Yes. Third term, what's the exponent? 0, right? So the biggest one we said is 2. Okay? All right. So that is basically the main terminology that I want you to know. Right? Can you figure out the name? Can you figure out the degree? The name that says talk about an expression, instead of saying that thing, you say, oh, that's that binomial, that trinomial. The degree lets us understand the shape. So we're not really talking about shapes in the grade 9 level. Over here on the left-hand side is some models sometimes used with polynomials. They can be used to help add, subtract polynomials, can be used for multiplying. I don't use them very often, but depends on who you have as your future teacher. They may use these quite a bit. So I do want to talk about them. Right? So these shapes represent the different terms. So looking at the terms here, could you make a conclusion or conjecture of what shape represents what term? What do you think, Ethan?
The big ones is the first one.
2 big ones are the first one. So the first term are x squares. Right? So we have this term's x squared, and we have 2 of them. That's why there's 2 of these drawn here. Okay? What do you think the rectangles represent? Lachlan?
The 4x.
The 4x. We have x, 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 and x, and we have 4 of them. Okay? So rectangles are x's, squares are the x squared. Okay. Then the small squares, what do you think those represent? The last one. And they represent just a value of 1. So 1, 2, 3, we have 3. Okay? Now, in general, if I'm working with these on a quiz or a test, I'll give you this as a legend. You don't have to memorize this. I'll give you that. But you need to know how to work with them if they ever do show up. So the only thing I didn't talk about those shapes is some of them were black, some of them were white. You correctly figured them out. So for the purposes of this course, black tiles are positive, white tiles are negative. Okay? So what they mean is the same. It's just the sign. If it's positive versus negative, that is different. All right? So let's try to come up with the expression for each one of these diagrams. All right? So the first diagram, so you got to go, what shape does this, what term does this shape represent? A rectangle, white rectangle. Right? So we're going backwards here, right? So what does this represent? You have the legend on the left-hand side. Taylor? Yeah, that's the negative x tile. Okay? And how about those small squares? What do those represent? The positive ones. So if we want to write this as an expression, we have one of these. So that's negative x. And we have 3 positive ones. So that would be plus 3. Okay. How about the next one? What does this term represent? What term does that represent, that shape? The big square. Right? And the fact that it's black. Right? You guys want to try these? I'll give you guys like 3 minutes. Yes, Tegan? Right? Thank you. I'll give you like, okay, so first shape, what is this?
A square.
The square, x squared. We only have one of these, so we're down x squared. Okay?
Plus
What shape is this?
x.
X. And it's positive, so we're down x because we have one of those. And we put down a plus sign because it's positive. Remember, we need to separate the terms. So every single one of these needs a plus or a minus in between them. Right? If it's positive, we put a plus sign. If it's negative, we put a minus sign. Okay, next one. What are these?
Oh, -2.
Negative 2. We have a negative 1 and a negative 1. There's 2 of them. So this is negative 2. So we have a minus 2. Right? So every term needs a plus or a minus in between them. That's how we separate them. Right? That's how we counted them. All right. So here, you can tell, we have 3 terms, 3 different shapes. Right? We have a shape, 3 shapes that we need to put in the values of. They're all being separated by plus and minus signs. So the first shape, big squares, right, are x squares. Are they positive or negative?
Negative.
Negative. White means negative. Right? And we have 2 of them. So that's negative 2 x squared. Okay. Rectangles. What does that represent? Negative what?
X.
Negative x. Thank you. Negative x, negative x, negative x. We have 3 of them. So we have minus 3x or negative 3. Right? Okay, last one. What do those squares represent? Little ones.
Positive.
Positive ones. And we have 4 of them. So that's positive 4. So we need to put down the plus sign in between here to separate the terms and to indicate that it's positive. All right. Jacob, turn around. Jacob, what's the answer for the next one?
Wait. 2 x squared,
Okay, yeah, these are the x squares. Okay.
and then minus 5. Negative. Yeah.
Minus 5, yeah. And we have 5 of these.
Yep.
Okay, so we need to be able to translate from the shape to the expression and from the expression to the shape. All right, so I'm going to put some more terminology here that shows up on the questions. All right, let's make up a question here. 2x squared plus 3xy plus 4. I'm going to talk about some terminology here, okay? Okay, so on here, letters mean variables. Right? So how many variables does this expression have? If I ask you that question. Not 3.
Oh.
So how many different letters do you see? What letters do you see?
X and Y.
So it has 2 variables.
Oh.
Has 2 variables, X and Y. Okay? Now the numbers in front, I'm going to change this question slightly from this 2 to here, and change that to a 5, just so it's something unique. So in the green, we have the -2 and the -2 and the +3. Those are numbers in front of variables. Numbers in front of variables are called coefficients. You may remember that from the first chapter, but that was a couple months ago now. So the -2 and 3 are called coefficients. Okay, numbers in front of variables. Okay. Then you had this lonely guy over here. A number without a variable. That is called a constant. Okay, a number without a variable attached to it. So you need to know what variables are. You need to know what coefficients are. You need to know what constants are. And on top of that, you need to know how to find a degree. You need to know what the names are. None of these things are very difficult, except for there's lots of these little things. So it's easy to get confused amongst them all. Right? So that's the tricky part of this chapter. All right?